Nationwide, approximately 83% of college students are commuters. To be considered a commuter, one must not live in institution-owned housing. This amount of commuters leads to a significant amount of students driving to class. The purpose of this project is to increase parking accessibility to student commuters who drive to campus. The proposed design utilizes a camera system to monitor available spaces. These cameras will communicate with a mobile application where users will be able to locate available parking spaces. Parking or poorly monitored parking proves to be a nightmare to virtually everyone. This September, the team decided to poll around 50 University of Miami students of various years regarding what improvements they would like to see on campus, and the most common answer was a resounding "fix the parking." This issue is not isolated to our campus, but to many others as well. According to Revel, the campus newspaper for Louisiana State University, one main issue plaguing staff parking is the distinctions between the type of parking available. Similarly to Miami, LSU has various passes available to students which cannot be interchanged during the hours of 7 a.m. to 4 p.m. The basis of this restriction is in theory to ensure that every student who purchases a specific parking pass is able to claim a spot during these hours. In a perfect world, this would be great, however, nothing is perfect. Anyone that has ever parked in the University of Miami red lot knows that this is rarely full during its restriction hours. However, there is still no option to use pay by phone for certain lots during restricted hours. Not only is this a loss for students who want to park in a different lot on a certain day, but also a potential monetary loss for the university. The probability of every student with a red lot spot showing up at the same time is arguably implausible. Let's say there's a slow day for parking. For example, only 20% of a certain lot is filled. Rather than keep the empty spots restricted, the university could open up 30% to be potentially used by pay by phone or other lot pass holders, still leaving overhead for about 50% in case the other pass holders show up. A system like this would be beneficial to the university and to students. However, to implement this, there needs to be an effective monitoring system. There needs to be something that keeps track of every spot to see if it is empty or not. Not only is this idea applicable to the original problem, but is essentially able to be implemented in practically any parking lot or parking garage. Parking sensors have been implemented before through various measurables, weight, temperature, etc. However, we moved to use a camera. The camera will snap a picture of a predetermined number of parking spaces in front of it. We will create software that can then compare this predetermined image with the current image to see how many spaces are available. This will not only allow users to know how many spots are available, but will also allow universities to be flexible with lot restrictions depending on availability of a certain day.
So our need statement, why do we need this system? So a lot of college students, if you ask them, they say that they want improvements to the parking situation at their universities. However, this just isn't going to happen anytime soon. The costs are way too high for a university to commit to something like this. We found that some parking spots go up to $30,000 per added spot. And so again, adding more spots is not feasible. So we need to look at alternate solutions, and even bigger picture, if we look at businesses and other places that utilize parking lots, they just cannot find space to build more parking spaces even if they wanted to. And so our application makes already existing lots more efficient, and so we are definitely needed because we can't just add more spots, so we need to make do with what we already have, and that is what we are in the business of doing. And so our objectives for this is obviously to design and deliver a system which shows available parking spaces within a lot. We're going to do this with a camera that's going to relay this information to our system and then to the user. And through this system, users will ultimately save time and have a better experience parking. And then parking lots nationwide on college campuses and hopefully other places will be optimized to use all of their space, because today we're seeing that a lot of these parking lots are not being used efficiently, which just is a waste of space, and isn't a great experience for everyone involved.
Proposed work. Our project will be divided into 3 separate aims. Our first aim is to design the camera module. This includes but is not limited to ordering any necessary materials such as a camera or any other hardware that we may need, and interfacing this and ensuring that the hardware will be a viable option for our camera. Our next aim is designing the application. This includes but is not limited to any coding necessary for our application or other design features within our application. Finally, our last aim is to assess the usability of our application. To do this, we will be interfacing our camera and our application to ensure that they are compatible with each other and ensure that they are user-friendly, among other things. Approach. We are to map an area and display the unoccupied and occupied parking spaces. We have decided after discussion with our advisor, Dr. John Nigel, that we will use an Arduino-compatible chip and camera module for the onboard image processing. We have decided that this will be beneficial to bridge the communication between the camera and the application. Plan of execution. The camera will be built around the Freenove ESP32W rover. The device includes an onboard camera with 8 GB of RAM. The camera will be built with a 3D printer and fastening system. The software component will utilize Flutter, Python, and Firebase. We have decided that this is the potential best option for our project.
Okay, so for the plan of execution, we plan on using an agile development method. From past experience, this is in labs, it's probably the easiest way to do this, especially from 414. The final project was done using this sort of methodology. For the projected timeline, at least from now until next semester, we believe the machine learning model and app development will take about 2 months. It's kind of a generous amount of time, but this is what we're least familiar with, so we think we'll need the most amount of time for that. And merging will take about 2 to 3 weeks. And the Gantt chart will get into specifics, but I think we'll be doing that around April, assuming we keep on track. Every 2 weeks, we'll have a sprint. So we'll meet at the end of that 2-week period to see where we're at, reassess, and hopefully that gets done on time. And for the timeline, we think we're at halfway through December right now, so we should have ordered the camera components, which we did. According to Dr. John, I went with his hardware specifications and ordered the camera module. It's here, and throughout break, me and Connie will be building it, testing it, seeing how it works, getting familiarized. There's a whole tutorial that we'd like to go through with it because it seems to be a pretty commonly used piece of hardware. We should also be able to, get some properties of the images that module can recognize, because resolution, depth of field, or field of view are all important things that we need to know. And that should be done by the end of break. Then the AI training and the machine learning, which will be done by Joey and Zach, will be during break, January and February, about that 2-month period that I was mentioning. And hopefully by around March or April, we can start combining the two, which would probably be around a month as best guess. And then finally, we will be testing it in probably the Merrick or Pavia parking garage, just to see how well this thing handles, and that'll be at the end of April. And then we'll end the semester by writing the report, assuming everything works correctly. So yeah, that's all, and thank you.